Okay, so we are live now.
Yes.
Sweet.
Okay. So I really haven't had a chance to do a lot of the homework yet. Have you guys done it yet?
Yeah, a little bit. I looked at some of it today and a little bit yesterday. I'm still trying to get the hang of everything, but
I read in the textbook, but I didn't really do any of the homework.
I did the first two, and then on the very bottom, I'm having a hard time understanding the third part of it, but I got the first two for sure.
for the extension problems?
Yeah.
Oh, okay. Yeah, I was actually too. The third part for me too was like difficult to still understand. Like I still kind of get some of it, but not very confidently.
Yeah. The second one on the third, like number 3 is divided into like 3 different parts. And the first two are just basically reminding you of equations. But on the third part, it has 3 different problems. The second one is pretty easy. The other 2 are not so easy. Or at least I don't know how to do them yet.
Okay. Sorry, I'm just pulling up the extension problems.
Let me know when you're, or let us know when you're ready.
Okay, you guys can start if you want. Oh, it's going to be like 5 seconds.
So the first one says, given 2 vectors, how would you find the resultant vector? Draw 2 vectors in the resultant vector. So back from the textbook, because I was going over this a little bit. So the resultant vector, or is also known as the sum vector. So that's when it was talking about like the a plus b. So when you're given a vector of a and a vector of b, so say vector a, it's those 2 points, right? So what it does is you add the first 2, so the first one of a and the first one of b to get the first resultant point, and then you do the second of a and the second of b to get the second of the second resultant. Does that make sense?
Yeah, I remember that was like the first 2 or 3 questions on the homework. I remember.
Yeah. So draw 2 vectors and give a vector resultant. So what we can do is, or I guess we would draw. I guess I'd keep it simple. So maybe the first vector would go, would be 0, 2. That's just, I feel like would be the easiest if anybody else has any.
Is this kind of like drawing the parabola thing?
It's like drawing like the 2. So you draw the 2 vectors, and then you have to figure out what the resultant one is.
It really doesn't matter where you put the 2 lines, as long as you can. If you use the resources they give you and you go to the Khan Academy, they actually have a few problems like this, and they actually show the videos of how they do it as well. And it basically is, if you have one line going here, just one line going like this, and then another one going like this, you basically, even if they're not even close to each other, you just take them from where they are and you put them together, and then you draw a line across, and that's where you get C. So it's A and B and C.
Because it makes the parallelogram, right?
Yeah.
Okay. That makes sense.
So, so what 2 vectors do we want to draw?
Do we just have to pick numbers?
Yeah. So just like 2 random vectors.
Let's just do easy ones then, like you were saying, the 0 and 2.
Okay, so 0, 2. So there's a vector going up to 2, and then we'll do another one that goes to let's do 5, 0. So the first one we have was 0, 2, and the second one was 5, 0. So to find the resultant factor, we'd have to add the first 2. So it'd be 5 plus 0, which gives us 5. And then add the next, or the last 2, which would be 2 plus 0, which is 2. So your vector would be 5, 2. So it'd go 5, 2. And then you draw one like that. So it looks like,
Okay. Yeah, it looks like what kind I got. Except yours is nicer.
does everyone get that?
Yeah.
Cool. Yes. Alrighty. This next one. So imagine the following scenario that involves vectors. When the prophet Joseph Smith was a young man, his father bought a farm near Palmyra, New York. As with many farms during that time, the family spent many days clearing land to make it suitable for farming. This would include cutting down trees and then pulling the stumps out of the ground. Sometimes this was done by hooking 2 chains around the stump and having 2 horses going in different directions pull the stump out. Imagine that the 2 horses have an angle of 65 degrees between them. One horse is pulling a force of 200 pounds, and the other is pulling a force of 300 pounds. The force would be the magnitude of the vector. What is the magnitude of the resultant force? What is the angle between each horse and the resultant force? So it says hints. Begin by drawing a picture. Remember that the parallelogram has 360 degrees and the opposite angles are congruent. So what we do, so you draw a parallelogram. And then we know the first part. So it says the 2 horses pulling away from each other, they equal up to 65 degrees. So that whole angle, the first bottom left angle, is going to equal up to 65 degrees. And then it says one horse is pulling a force of 200 pounds and the other is pulling 300. So we would label the shorter side 200 pounds. And then the longer side, we would make 300 pounds. Okay, so then we need to find out what the middle force is, and then what the angle is between those two, or between what those two angles are from the resultant force and the force on the sides.
Mm-hmm.
So what I remember, if I remember correctly, is that the middle force, so the resultant force in the middle, is one side plus the other.
I think you're right. If I remember everything.
So if you have like the B vector and then an A vector, the middle resultant vector is A plus B or B plus A. So the middle part would be 500 pounds. The resultant force would be 500 pounds, right?
Yeah, because they combine together.
Right.
It wouldn't be that, because you have to use the law of cosines on that. Because it's not like if you check the answers, it's gonna show you something completely different, because you have to use the law of cosines, because it's like having a regular triangle. Like if you're drawing the picture, and I actually drew it like that, it's just like having a triangle. So you're using the same rules as if you were solving for a triangle. Like,
wait, can I see that again? Can you hold that up one more time?
Yeah.
Why would they put that in the book then?
Oh, I think I get it. Okay, thank you.
Okay.
And if you're using the law of cosines, and the law of cosines is c squared equals, you know what, I might have written it differently, but it's c squared equals a squared plus b squared minus 2 times a times b times cosine of the degree of c.
Okay, that's right.
And so you would write it out as 300 squared, or the way I wrote it out was 300 squared plus 200 squared minus 2 times 300 times 200 times cosine of 115 degrees, because we know that one side is 65, so we also know the other side is 115 degrees because it has to add up 180. So that middle angle on both of those is 115 degrees.
Okay.
And so all of that is equal to r squared. And if you plug it into your calculator, that's basically the only way you can do it, because of that cosine. You'll actually have the r equals the square root of 100. Well, I'll just say the answer. It's r equals 425.1 pounds.
Okay. So what was the equation you said? So you use the law of cosines. So C is that middle one, right? Is the side that we're looking for?
C. I just wrote it as r. So we're trying to find this. We're trying to find this middle line right here. That r.
Right.
That's r. And so we're that C at the very end, the cosine, is the this let's see, right here, this angle right here, that's the 115 degrees. That's
Okay.
my C.
Oh, okay. So you used the law of cosines, but you substituted R or C for R. Is that what you're saying?
Yes.
So it turns out to be R squared equals A squared plus B squared minus 2AB cosine of R.
Yes.
Okay. So then,
Wait, sorry, say that again.
Are you using another r for that angle? Because my r is just that line, that straight line across there.
yeah, I meant like the cosine of R, like the angle that R is represented.
Oh, yes, opposite of that. Yeah.
Yeah. So which would be the 115?
Yes.
Okay. Did you need to hear that again, Monique?
No, I get that 115, but what do you, like you said, there's something like r squared plus.
Oh, so when he said, you know how he said the C squared equals A squared plus B squared, the law of cosines?
Oh yeah.
So instead of C, we're using R because R is, in this chapter, they use that resultant force as R. They label as R.
Instead of C. Okay.
So you just replace R instead of the C.
Okay.
And then when you get to the angle part where you get the cosine of what we would say R, it would just be the cosine of the angle that is is
Opposite. So 115, right?
yes.
Yeah.
All right. So let me just make sure I do this all right. I don't know why they would say that then in the book if it was going to say if A vector and B vector, that the resultant would be the addition of both those. I don't. That should be. And you don't round anything right until the end. Is that what you?
Yeah. Yeah. Okay. I'm trying to think of a way. So on the I don't know, I haven't done any of the homework for it. I just seen the Khan Academy videos.
Yeah.
I know that it's not just the two angles or the 200 and 300 added up, because if it were that, it would basically be two lines that are just going straight. Because we have one that's straight and one that's kind of angled.
Yeah.
It's not exactly the 500. I don't know if that makes sense. It's just that if it were straight, it would just be the straight 500. But since it's angled, it doesn't add up completely to the 500. And that's why we have a different number there.
Yeah, I get. I didn't get the answer. So r squared equals 200 squared plus 300 squared minus 2 times 200 times 300, the cosine of 115.
Cosine of one.
I put, so I set it up with like r squared equals 300 squared plus 200 squared minus the 2 times 300 times 200 times cosine 115 degrees. And then if you simplify that down, you would have r squared equals 130,000 minus 2 times 300 times 200 times cosine 115. If you keep simplifying it, it'll be r squared equals 130,000 minus 120,000 cosine 115. And I tried to just subtract 130 minus 120, but it won't give you the right answer.
Because it's time that.
Yeah, you have to times it by the cosine first. So, but I just went ahead and just brought the squared over, so it would be r square root of all of that. And if you put in the square root of all of that, 130,000 minus 120,000 times cosine of 115, it'll give you the pounds for r.
Okay. Make sure.
Okay, so I got 425.1.
Yeah, that's what I got as well. Now that I finally got it. Okay, so we know that the resultant force, so we know the force is 425 pounds, or 425.1 pounds. So now we just have to figure out what the two angles are from there. And the easiest way to do that would be the law of sines, right?
Yeah.
Okay. So what we would do, so the first one, so it'd be
So sorry.
425.1 over 115 equals 300, or the sine of 115, sorry, equal over 300 over the sine of, I guess, what would you call that, b? Beta?
I called it b, but it can be
I don't think it
anything
matters.
really.
Yeah.
Okay, that's it. All right, and then you just solve for the sine. The sine of 115 times 300 divided by 425. And you have to take the negative sign. So for beta, I got 39 degrees, 0.8. Do you know how far they round it, Antonio?
It's 2.
It's 2? Okay,
2
2.
decimals, yeah.
39.76.
Yeah.
All right, so then if we know that angle, then we can find the other one by subtracting or doing 65 minus 39.76, which gives us the other one is 25 degree or 25.24.
Yep.
That's what I got too.
Okay. All right, so we found the resultant force and we found the two angles, right?
Yeah.
Yeah. So 421.1 pound and then 39.76 and 25.24.
Okay. Nice. Wasn't too bad. Okay, so now the next part. So in the group hangouts preparation assignment, you learned what a polar coordinate is and how to compare the coordinates using the graphs and formulas. Now we want to consider how to convert Cartesian equations to polar equations and vice versa. All right, so from the prep, you should have developed the following formulas. Given r in the angle, then x equals r cosine of an angle, y equals r sine of an angle. Given x and y, then r squared equals x squared plus y squared, and then r equals the square root of x squared plus y squared. And then tangent angle equals y over x. We can use these formulas to convert the two equations. Here's an example to get you started. So we're given r, 2 cosine of an angle. So we need to get rid of the r in the angle. So using the above formulas, we consider how we can do substitution. Initially, we can see that if it was r cosine angle, we could do substitution. The r equals 2 cosine of an angle. So that's r squared equals 2r cosine of an angle. And then that turns out to be x squared plus y squared equals 2x.
What? I did not.
You call it angle. Cosine theta is just basically x. It's on the unit circle, or it's out of the unit circle. Cosine theta is x, and sine theta is y. That's just basically what it is.
Oh, okay.
Are we changing it to
And then
Y's?
What was that?
Sorry, are they asking us to change it to x and y's then?
Yes.
it wants the actual equation. And I think because r squared equals x squared plus y squared, that's where you get the x squared plus y squared from in that equation? Yeah. Okay.
Yeah.
All right. And then r cosine theta equals to x. So they just substitute that in for x.
Yeah.
Oh, okay. That makes sense. And then it says complete. It looks like it's a circle, but it's not. So completing the square, we can rewrite the equation so we can identify the center and the radius of the circle. So they changed it, so they put it in that circle form or unit, right?
Yeah.
Okay. Oh, okay. Oh, so they subtracted the 2x over and then did the complete the square with the x's, right?
Yes.
Mm-hmm.
Okay, that's what I'm seeing there. Okay. All right. Now it says, now you try. Convert the following equations. So we have y equals 3x minus 2. So if we're given y and x, so we can substitute y and x, right? And then we just have to get r on the other side.
Yes.
Yeah.
You gotta get r alone,
Right.
I think.
So y from the beginning, so y equals r sine of theta. And so we'd have r sine of theta equals 3r cosine of theta, because that's what x equals, minus 2. So now all we have to do, now we have to get the r's by themselves. So I guess the best way to do it, so I would add 2 to the other side and then subtract the r sine theta from the other side. So that what it comes out to be is 2 equals 3r cosine of theta minus r sine of theta. And then you would just factor out the r. So what it would be 2 equals r parentheses 3 cosine of theta minus sine of theta, all in parentheses. And then I guess you would divide by r, right? So then it comes. Did I do it wrong or no?
No, I don't know. Let's keep on going through it. So I'm sorry. I'm just trying to think of.
Oh, was I going too fast?
No, you're good. You're good. I'm just thinking of. I was just thinking of. I was looking at the next one, so I was a little confused. My bad.
No. So then what I would get is I have 2 over r equals 3 cosine of theta minus sine of theta. And then this you would multiply by the reciprocal. So 1 over 2 to cancel out the 2. and then you multiply the other side by 1/2. So what it comes out to be is r equals 3 cosine of theta minus sine of theta over 2. Does that work or no?
I think it does.
Let me see here. That's not what it gave.
Did you say 2 different signs of theta?
What?
Did you say? I didn't get what that last thing that you got.
Which part?
So did you say 3 sine of theta?
No, I said 3 cosine of theta.
Okay. That's what confused me. Sorry.
No worries. So I had 3 cosine of theta minus sine of theta over 2. But the answer that they have is r equals -2 over the sine theta minus 3 cosine of theta. So what it looks like they did is they went the other way. So they subtracted the 3r cosine of theta over first, and then pulled out the r, and then divided the whole thing by -2. If anybody else sees that.
Yeah, I see.
And then to get r by itself, then you would now then divide by the reciprocal, or times by the reciprocal.
Yeah, so they did r. So what we originally had, so it was r sine of theta equals 3r cosine of theta minus 2, right?
Yes.
So what they did is they subtracted the 3r cosine of theta first to the other side, so you get r sine theta minus 3r cosine theta equals -2. And then they pulled out the r, so you get r parentheses sine of theta minus 3 cosine of theta equals -2. And then they divided that whole thing over to the other side.
Yeah, that's exactly.
So, I mean,
but the same answer, right? But essentially, it just depending on how you.
I mean, I would assume so. I don't see how my way would be different than the other way, right?
Yeah.
I wonder if you plug it into a calculator, if it would give you the same thing.
You want to try it just for two?
I mean, we could try, yeah.
Okay. Let's do 45 degrees as the angle then.
Why don't we just do like 9? We'll just actually 90s.
Yeah.
Why don't we just do 90?
Yeah. Just do one.
Are you gonna do it your way? I'll plug in the.
Yeah, I'll do it my way. So my way, I got -1/2.
Kind of. We're doing 90, right? Yeah.
Yeah.
So it's really hard to use this calculator on the computer. And what'd you get?
I got -1/2.
I got -2.
Uh-oh.
Because
Look at the answer to see which one it was supposed to be.
here, why don't we try?
Prove that it was right.
I'm gonna. And
What was
also,
that? I was answering a phone call.
yeah, no, I'd
You got -2?
yeah, I got -2 because sine of 90 is 1, and then cosine of 90 is 0. So it's just -2/1, because it'd be -3 times 0.
Huh. So then if I did it my way, then so it'd be 0 minus -1 equals -1/2. Huh. Maybe the way you did it first.
No, didn't you take a? Let's see. I think you may have in your way. I remember you talking about a reciprocal. Maybe you didn't have to take the reciprocal of something. Because I mean,
Oh, yes. Okay, so yes. Okay, I see what I did wrong. Because when I had it, I multiplied by 1/2 to get rid of the 2. But what it did, it still left it as 1/r.
okay,
So if I took the inverse of that, which gives me r by itself, it would just flip. It would reciprocate my answer.
yeah,
So it would turn out to be the same thing then.
okay.
Oh yeah.
So you just took one extra step.
Yeah.
They didn't need to. Okay.
Well, I forgot to do one extra step. That's what I forgot to do.
Okay.
So, but yeah. But I guess the best way to do it is what I'm noticing is that you want to try to get the r on the left side.
As soon as possible.
Yeah, to start out with.
Yeah.
So, all right.
Okay, the next one.
Everyone understand that?
Yep.
Yeah.
Okay, cool. All right, so the next one is x squared plus y squared equals 9.
Wouldn't it just be because x squared plus y squared equals r squared, so 9 equals r squared. So you just take the square root of that and you get 3.
Plus or minus 3.
Plus or minus.
Yeah, plus or minus.
Oh, plus or minus 3, yeah.
Yeah. Nice.
That one's easy.
That almost wasn't too bad.
Hope that one's on the test.
For real. All right, here's the last one. So r equals 3 over 1 cosine of theta. Here we go.
Fun.
This is fun. So r equals 3. So we have to find. So if we're given r, which way do we have to go, or what are we trying to find?
Wouldn't it be we're trying to solve for y because
No, wouldn't it be x because it's I don't know.
Give me 1 second.
I think I think it is x actually.
Because it's cosine theta. But I'm just correlating the two. I'm not really. That's not a very valid reason. It may not be a valid reason, but that's just what I'm thinking. We could
say that Khan Academy covered this kind of stuff too. Antonio?
What?
Did you say that the Khan Academy that you looked at, did it cover this kind of stuff too?
Yeah.
I mean, wouldn't it, now that I think about it, wouldn't it be x because you can't solve it for y if there's no sine theta?
I was thinking
you use cosine theta to solve for x, and that's the only thing we have.
What was the sine of 90?
Sine of 90
Yeah.
is 1.
Or 1.
So I was just thinking, what if they did give us the sign, but they gave it to us in sine of 90, and that's why we have that 1 there.
Oh, that's good.
Because I was thinking you have to multiply over 1 minus cosine theta over. So really you would have r, and then in the parentheses you would have the 1
Oh.
and then minus cosine theta. So if you multiply that into it, you would have 1r minus r cosine theta equals 3. And then you could turn that r1 into r sine theta minus r cosine theta. So it basically is y minus x. I think, I don't know.
But then at that point we'd have to assign, it wouldn't be theta, it'd be 90. You could
Oh,
just
yeah,
solve
yeah.
it at that point. Or it wouldn't be, actually it wouldn't be theta. Theta would still be there, it'd just be sine 90.
Yeah.
Or
It'd be-
here's
so I
maybe
don't know.
I'm thinking of is so say you multiplied the 1 minus cosine theta from the one side to the other side. So then what it comes out to be is when you factor it, you get r minus r cosine of theta equals 3.
Yeah, that's what I. Yep.
Is that what you're saying?
Yeah.
Oh, sorry. I'm sorry. I was doing something. I didn't mean to repeat you.
I just don't know how you would get, because I'm pretty sure you have to have y in there somewhere, but I don't know how to put it in so that it would actually be there.
You have to get, if you could get rid of that 1, you could do, I think you could make it so that cosine theta is x. And then you get x equals whatever. And I don't know if that would work.
Well, if you factor out the r, that would be an r squared. Isn't r squared the same as y squared?
Or maybe what I'm thinking is that they substitute the r for the square root of x squared plus y squared. Because you know how r equals the square root of x squared plus y squared?
Uh-huh.
So they substitute that r in for x and the y. So what it comes to, the square root of x squared plus y squared equals 3 over the 1 minus cosine theta. That's where you get your y from and your x.
So is it really square root of x squared plus y squared and then times the 1 minus cosine theta equals 3?
So maybe you know how I repeated you, Antonio?
Yeah.
So what if we did that? So we get r squared, or we get r minus r cosine theta, and then we substitute the r for the square root of x squared plus y squared, and then we substitute the r cosine of theta for x.
Yeah.
So
it wouldn't be squared though after taking that square root off of it, would it?
Oh, wait, hold on.
what do you mean?
Because it's the square root of x squared plus y squared. Wouldn't they just be x plus y? Oh, wait, never mind. I don't know where I'm at.
So I'm gonna try it that way real quick, Antonio. I'm gonna try that real quick just to see what it gives us. So if I do 1 minus cosine theta to the other side, and I distribute it, so I get r minus r cosine of theta equals 3. And then I would substitute that in for the square root of x squared plus y squared minus x equals 3.
Squared.
So what I would do is I would have to add So I add x to the other side. So the square root of x squared plus y squared equals x plus 3. And then I'd square root both sides to cancel that square root. Then I'm left with x squared plus y squared equals x squared plus 6x plus 9. And then I would minus the x squared. Minus the x squared just to get rid of it. And y squared equals 6x plus 9. What in terms of what do we have to solve this in terms of? Do you know?
It's X and Y.
Yeah, I think it's just X and Y.
Are we solving for both x and y, or are we just solving for one, y or x?
Shoot. That's where I'm stuck at.
So did you how did you move that 1x over? Did you just add it over?
Yes.
So when you
Yeah, so I added the x over.
Okay.
So what I got, so if you still followed me, so I had the square root of x squared plus y squared minus x equals 3.
Yeah. Yeah, I got that. And then
Yeah, so I added the x over.
okay.
So then I have the square root of x squared plus y squared equals x plus 3. And then I squared both sides so that the square root canceled on that side. And then you have to factor the x plus 3 squared. So then I have x squared plus y squared equals x squared plus 6x plus 9.
Okay.
And then you wouldn't, I don't think you do the square root of that. So, oh, okay. Oh, yeah, no, yeah, yes, okay. Shoot, sorry, I'm thinking.
None of my ways are working.
Okay, so I
keep on trying to figure this out and I can't.
This is the one I'm stuck on. So what I'm looking at in the answer is they have it in terms of x. So the way that you would get it in terms of x, so did everybody get to the y squared equals 6x plus 9? So what you would
Yes.
do is you do the minus 6x to put it on the other side and minus the y squared to the other side. So you get negative 6x equals negative y squared plus 9. And then you divide by negative 6 on the other side. So then what it comes out to be is x equals y squared over 6, because the negatives cancel out, minus 3 over 2. And that's how you get the answer. But I don't know why it would tell us to, like, it wouldn't tell us to solve it in terms of x or whatever, or y, you know?
Yeah.
Yeah.
Because technically you'd be able to do either one, right?
Yeah. But that's what I'm confused about. So
But that makes sense.
Oh, wouldn't it be because you have to still keep the format of x squared plus y squared equals r squared? So you have the x first, and then you have the y second, and then the r. So in this case, the x is just alone, the y squared is just divided by 6, and then the r is the 3/2. I think that's why it's set up like that.
Oh, that makes sense then.
yeah, I could see that.
Just implied that that's the form that it should be in.
I think so.
Okay.
All right. Was that the last of it?
Yeah,
All right.
it wasn't too bad. I mean, except for the part.
Yeah. I feel like later in the week it'll get harder though.
Oh yeah. Probably.
Once we get more into the homework, because this, I don't know, this stuff's kind of confusing.
Yeah, it's confusing to me.
That last one, I still kind of.
It still kind of leaves you like thinking, huh?
Yeah.
It makes sense, but how did like? But if I didn't know the answer, like I don't know if I would know.
I would have never gotten that right if we didn't have access to the answers.
Yeah.
I'm gonna have to try and study before the group quiz then in that case, because I don't want to mess up this group quiz. Speaking of which, I'll make sure to email her, see if she could open it or not. She probably couldn't, so I'll just I may have to send an email from a different account to her.
Okay. Yeah, and then if you'll just let us know if you find out anything.
Okay.
That'd be awesome.
Sweet.
Okay, I'll submit this link in tonight if that's okay.
All right. Sounds good.
Okay. All right. Thanks, guys.
All right,
Problem.
sounds good. Thanks,
See ya.
guys.
All right.
Oh wait, are we meeting Thursday at the same time, or is that where?
Yeah.
Is
Yeah.
everyone good for Thursday?
I'm
good.
okay.
And then
Okay, I just want to make sure. Sorry.
Yeah, I'm good for Thursday as well.
Huh?
Who is submitting the link for tonight?
Monique.
Awesome.
Okay. Okay, cool. Yeah. All right, sounds good. Thanks, guys.
All right. Thanks, guys.
Bye.
Bye.